Good morning to everyone. I think you can see the slides now. So this is a last topic in Unit 4. That is a moment of inertia. I think in the last class we discussed mass. Okay. So now we will discuss problems in moment of inertia. So, okay, I think you need these formulas: moment of inertia about x-axis, moment of inertia of the lamina about y-axis. Okay, I will start from here. If a particle of mass m of a body be at a distance r from a given line, then mr square is called the moment of inertia of a particle about the given line. And the sum of a similar expression taken for all the particles of the body is summation m r square. You take a summation, okay, is called the moment of inertia of the body about the given line. So that is explained in this figure. If m is the total mass, capital M is the total mass of a body, and we write its moment of inertia is mk square, where k is called the radius of gyration of the body about the axis. Moment of inertia about a lamina. So consider the elementary mass rho into del x into del y at a point p of x comma y of a plane area capital A, so that its moment of inertia about x-axis is equal to rho into del x into del y into y square. So from this we have moment of inertia of the lamina about x-axis, that is ix, I suffix x is equal to double integral over a rho y square into dx dy. Similarly, moment of inertia of the lamina about y-axis iy equal to double integral over a rho x square into dx dy. Also, moment of inertia of the lamina about an axis perpendicular to the xy plane, that is about z axis, is using perpendicular axis theorem. Okay, you can add these two. So iz equal to ix plus iy, that is double integral over a rho into rho is common x square plus y square into dx dy. Okay, so now next result, please write the next result. Moment of inertia of the solid. I think the previous slide is deleted, so I will copy and then paste it and then upload. I will upload in the GCR. Okay, so moment of inertia of a solid. So moment of okay. So these three results you should remember: 1, 2, 3. So moment of inertia of solid about x-axis is denoted by ix, that is equal to triple integral over v rho into y square plus z square into dx dy dz. Okay, I think you know that. So this is coming from, if you take a point on the x-axis, okay, you have x comma 0 comma 0, then the some general point is x comma y comma z. Okay, well, the distance between these 2 points is you should put what, root of x minus x 0. Okay, well, so y square plus z square. Okay, and then m r square. Okay, r square is what? R square is y square plus z square. So here you have y square plus z square. So similarly, you can find moment of inertia about y-axis Iy equal to triple integral over v rho into z square plus x square into dx dy dz. Moment of inertia about z-axis is Iz equal to triple integral over v rho into x square plus y square into dx dy dz. Okay. And then theorem of perpendicular axis is yeah, here it is. Yeah, sometimes we require the moment of inertia about a body about axis other than the principal axis. So the following theorems prove useful for this purpose. Theorem of perpendicular axis. If the moment of inertia of the lamina about two perpendicular axis, that is OX, OY in its plane, that is about x-axis is IX, about y-axis is IY, then the moment of inertia about z-axis is IZ, that is equal to sum of IX and IY. And then Steiner's theorem or parallel axis theorem. If the moment of inertia of a body of mass capital M about an axis through its center of gravity is I, then I dash is the moment of inertia about a parallel axis at a distance d from the first axis, okay, is given by I dash is equal to I plus md square. Whether you studied these formulas in physics or?
Yes, sir. 11th physics, I think.
Perpendicular axis theorem and
Parallel axis theorem.
Perpendicular axis or parallel axis theorem, I think you studied.
Yes, sir.
Yes, sir.
Okay, what about the remaining thing? Perpendicular.
Perpendicular axis theorem, parallel axis theorem, sir, படிச்சிருக்கோம். அதுக்கு முன்னாடி நீங்க சொன்னதெல்லாம் படிக்கல.
Okay. Okay. So I think you studied these two. Huh?
Yes, sir.
So இது ரெண்டும் படிச்சுனா அப்புறம் IX IYலாம் தெரியணும்ல.
Sir, we didn't use triple integral or double integral, sir. We just use
just a concept.
MR square. Yes, sir.
Concept. Okay. Yes, I understand. Because in plus 1, plus 2 level, you study only single integral. Yes, I know that. Yeah. Okay. Yes. Okay, now we will go to the problem. First problem. Find the moment of inertia. I'll write short form MI. Moment of inertia of a quadrant of ellipse x square by a square plus y square by b square equal to 1 of mass capital M about the z-axis if the density at a point is proportional to xy solution. So here we need to find the moment of inertia about z-axis. Okay. Of a quadrant, it is not given exactly which quadrant, so you can take the any quadrant. So I will take the positive quadrant for my convenience. x-axis, so this is y-axis. Okay, so this is a portion of ellipse x square by a square plus y square by b square equal to 1. This is the origin. This is the point A comma 0. This is a point B, 0 comma B. Okay, what is given the question? So rho is given, okay, density, okay, density is given, rho is equal to, rho is proportional to xy, so that's why I'll take rho is equal to k into xy. Okay, and then to find what? To find, we need to find moment of inertia, mi about z-axis. Okay, that is Iz equal to Ix plus Iy. So now I am going to find Ix. So before finding Ix, okay, what is Ix? Ix is equal to double integral over A, rho into y square into dy, dx dy. But what is rho? Rho is
KH.
kxy. So I should I should know the value of the constant k. Okay, in terms of mass, in terms of mass m. So that's why first I am going to find mass m. Mass m, that is we discussed in the previous class, double integral over r. Is it correct? Please check it. What is the formula here? R A. I think double integral over A. Is it correct? For a plain lambda, okay. Okay. Even you can give R because it is a region. Okay. Okay. Otherwise, you can give A. Same notation you can use. Rho into dx dy. So this is equal to double integral. Rho is kxy. Okay, dx into dy. So x here, here y. So x varies from, x is varies in this strip. Okay, parallel to x-axis. Here x is 0. Find out the value of x here. Sorry?
X equal to root of 1 minus y square by a square.
Where? Here.
Sir.
A by B root over B square minus Y square.
Yes, correct. Yes, correct, Tritriman. X is equal to A by B root over B square minus Y square. Because x square by A square plus Y square by B square equal to 1. We need x square by A square. Okay, 1 minus y square by b square. So from this, x square equal to what? A square into b square minus y square divided by b square. So from this, x is equal to a by b root of b square minus y square. Actually, plus or minus, we are in the positive quadrant. That's why you have the plus one, positive. Okay. The remaining part is you need to integrate. So y varies from 0 to b. So this is equal to k is constant. So you can try independently if you know how to, because you know enough practice already. So 0 to b, okay, y into x dx. If you integrate x dx, x square by 2, limit is from 0 to a by b into root of b square minus y square into dy. So 1 by 2 is constant. K by 2 integration 0 to b y into upper limit a square by b square into b square minus y square. So this is the upper limit. Lower limit is 0. Lower limit is 0 into dy. Okay, so you have what? K constant is k a square by 2b square. Okay, limit is from 0 to b. And then yes, b square y minus y cube. B square y minus y cube into dy. Now integrate with respect to y. So k a square by 2b square so b square into y square by 2 minus y power 4 by 4. Limit is from 0 to b. Substitute the limits.
That's k into a square b square by 8.
K into a square b square by 8. Correct, Kavimani? Correct. From this, you should find k in terms of m. K a square by 2b square. Okay, upper limit. What is the upper limit? B square, b power 4 by 2 minus b power 4 by 4. Lower limit is 0. So this is equal to k a square by 2b square. This is b power 4 by 4. So you will get here b square, here have b power 4, k a square b square by 8. So actually this is m. Okay, this is m. I need k. So k equal to 8m by a square into b square. Okay. So now I am going to find Ix, moment of inertia, about x-axis. So do it. I think if you know this formula, Ix is equal to double integral over a rho into y square, rho into y square into dx into dy. Rho is what? Rho is kxy into y square into dx dy. Okay. So here again, x varies from the same limit, 0 to a by b root of b square minus y square, and y varies from 0 to b, and k equal to what? K equal to 8m by a square b square. So that is constant, 8m by a square b square double integral y equal to 0 to b, x is equal to 0 to a by b into root of b square minus y square into x y cube, x y cube. So y cube into x into dx into dy. The reason is now I am going to integrate first with respect to x. So keep y cube here. It is better to, you can keep y cube here. Okay, x dx dy. X dx and then dy. Okay. First integrate with respect to x. So if you integrate with respect to x, you will get 8 m by a square b square integration y equal to 0 to b y cube x square by 2, limit is from 0 to a by b root of b square minus y square, so into dy. So substitute the limits, 8 m by a square b square, so integration y equal to 0 to b y cube, here have 2, so I think 2 means 4m, 4m. Okay, so if you substitute the limits, a square by b square into root cancel, b square minus y square, a square by b square into b square minus y square into dy. Okay, so now a square gets cancelled, 4m by b power 4. Okay, integration y equal to 0 to b square into y cube. So b square into y cube, if you integrate, okay, first write y cube minus y power 5 into dy. Now integrate. Anybody got the answer? B square y power 4 by 4 minus y power 6 by 6. The limit is from 0 to b. Sorry? M b square by 3. Yeah. I'm not getting, the voice is breaking. Okay, so 4m by b power 4. Okay, here b power 4, b square, b power 6 by 4 minus b power 6 by, sorry, b power 6 by 6.
Yeah, b square by 3, sir.
Okay, please write. Lower limit is 0. This is b power 6 by 6. Lower limit is 0. So if you take 12 4m by b power 4, I think b power, it's b power 6 here, so b power 4 means b square. Okay, here if you take 12, you have what?
2 by 24.
3 minus 2 by 12. So final answer m b square by 3. So this is actually Ix. Now, similarly, you need to get what? Iy, moment of inertia about y-axis. What is your what you are expecting?
MA square by 3, sir.
Yeah, ma square by 3, because the reason is it is your it is this is a rho is what? Kxy. So it is a symmetric x power 1 and y power 1. Okay, va? So you'll get m a square by 3. Okay, I will do it. Moment of inertia about y-axis is Iy is equal to double integral over a rho into x square into dx dy. Okay, this is equal to double integral over a. Rho is what? K xy into x square into dx dy. So k, we know that 8m by a square b square. Integral same limit y equal to 0 to b, x is equal to 0 to a by b into root of b square minus y square. What is the integrand? Integrand is x cube y. Okay, x cube. I'll write y here, y dy here into dx. Okay. So this is equal to 8m by a square b square. Y equal to 0 to b. Y dy. If you integrate this, x power 4 by 4. Limit is from x is equal to 0 to a by b root of b square minus y square. Okay. So now substitute the limits. This is the 4, here have 8. So 2m by a square b square. Integration 0 to b y a power 4 by b power 4. Okay, and x power b square minus y square whole power 4 is b square minus y square. Okay, whole square. Because if you multiply 4 times, you will get b square minus y square whole square into dy. Okay, now here you have a power 4, here you have a square. 2m a square by b power 6, a square by b power 6, integration y equal to 0 to b. What is the integrand? Y into, expand this, b power 4 minus plus y power 4 minus 2 b square into y square into dy. So this is equal to 2m a square by b power 6. If you integrate this, you will get b power 4 into y square by 2 plus y power 5. So y power 6 by 6 minus 2 b square is constant. Y into y square y cube. If you integrate y cube, y power 4 by 4. Limit is 0 to b. So this is equal to 2m a square by b power 6. Upper limit is b. So b square into b power 4, b power 6 by 2 plus b power 6 by 6 minus b power 2 6 4 b power 6 by again 2. Okay, lower limit is 0. I think you can cancel these two. If you cancel these two, you have only b power 6 by 6 this term. If you multiply these two, b power 6 gets cancelled. Ma square, here have 2, here have 6. So ma square by 3. So this implies this is actually I y. So by theorem of perpendicular axis, okay, moment of inertia, moment of inertia about z axis is Iz equal to Ix plus Iy. So that is equal to this is actually m b square by 3. This is m a square by 3. So if you take commonly m by 3, you have a square plus b square. So this is the final answer. Okay. So we go to the second problem. Prove that the moment of inertia of the area included between the curves y square equal to 4ax and x square equal to 4a about the x-axis is 144 divided by 35 into ma square, where capital M is the mass of the area capital M is the mass of the area included between the curves. Actually, we solved a similar type of problems in the double integral. Okay, similar type of curves. That is, find the area between the parabola y square equal to 4ax and x square equal to 4ay. So I think you have x square equal to 4ay. And and then y square equal to 4ax this is x square equal to 4ay. So this is the origin 0, 0, x-axis, y-axis. So this is the point A. So what is the A? Already we solved a similar type of problem. That's why I'm asking, what is A?
2, 1.
No, the one?
Sir, A, comma A.
No.
Sir, 4 into AB square by AB square whole power 1 by 3, sir.
No. X square equal to 4ay and y square equal to 4ax. Okay, from this,
Oh.
what is?
Sir, 4A,
Ah,
comma 4A, sir.
yeah, 4a,
1, 1.
4a, 4a is correct, Purnachandra. One is not correct, Shailaja. Please check it.
Okay, sir.
So x, what is x from here? Okay, y square by 4a. So I will take x square equal to 4ay. So what is x? Y square by 4a whole square equal to 4ay. So y power 4 equal to this is a 16a square. So here have 4, 64a cube into y. Okay, or you can write y into y cube minus 64a cube, okay, is equal to 0. So from this y equal to 0, okay, y equal to 0, or y cube equal to 64a cube means y equal to what? 4a. Okay, if y equal to 0 implies x is equal to 0. If y equal to 4a, y equal to 4a implies x square equal to what? 16a square, x is equal to 4a. So 0, 0 is the intersection is what? Intersection point is 0, 0 and 4a, 4a. So it is better to solve and then write. Okay. 4a, 4a. Yes. Now, so this is the common region. Okay. This is the portion. Now we need to find what? We need to find moment of inertia about x-axis. Okay, that means what? We need to find Ix is equal to double integral over a rho into y square dx dy. But rho is what? Whether it is given or not, the question. Okay, I think it is not given the question, but the final answer is in terms of what? M. So first you need to find the mass M. M equal to double integral over a rho into dx dy. Okay, from this find m in terms of rho, and then finally rho in terms of m. Substitute rho in terms of m here, and then find the final answer. So this is the idea. So first now I am going to find what? Mass. So mass m equal to double integral over a.
Sir?
Yes.
Sir, way to use double integral and way to use triple integral, sir.
For the plane lambda, okay, you should use double integral, Purnachandra. Okay. For a solid, you should use triple integral.
So solid means ellipse like that, sir.
Not ellipse, ellipsoid. Okay.
Okay.
So three-dimensional figure. Okay, three-dimensional objects.
Two-dimensional only double integral.
Two-dimension means only you need to use double integral.
Okay, sir.
Okay.
Okay.
So mass m is equal to double integral over a rho into dx dy. Okay, rho is, I don't know now rho, so double integral over a dx dy. Okay, dx dy. So now take a strip parallel to x-axis. So what is x here? What is x here? X is equal to y square by 4a. X is equal to y square by 4a to where?
2 root AY.
2 root a is correct with the one. 2 root ay. And y varies from where to where?
0 to 4A.
0 to 4 is correct. Into dx dy. So now you should integrate. Anybody got the answer for rho in terms of m? Okay, you can try. If you got the answer, you can tell rho into y equal to 0 to 4a x. If you integrate dx, you'll get x. So x is equal to y square by 4a to 2 into root ay into dy. Okay, substitute the upper limit rho into integration y equal to 0 to 4a. Upper limit is what? 2 root ay minus y square by 4a into dy. This is equal to rho into okay 2. Okay, I'm going to integrate now. 2 into root a. This is y power half. Root y power half. Root y is y power half. Y power half plus 1 is what? 3 by 2 by 3 by 2 minus y cube by 3. 3 into 4, 12. 12a 0 to 4a. Now substitute the limits and get the final answer. So if you substitute the limits, you will get what? Upper limit is what? Rho into, this is 2 into 2, 4. 4 root a by 3. This is 4a power 3 by 2 minus 4a cube by 12a. Lower limit is 0. So this is equal to rho 4 root a by 3.
Rho 16a square by 3.
16 rho m.
M is equal to rho 16a square by 3, sir.
Yes, yes, yes. So rho equal to
3m by 32a square.
3m by 16a square.
16a square.
Yes, yes. Correct, Parmesan. Very good. 4 root a by 3 This is actually what? 4a into 2 into root a. Okay, 4a power half. So minus, this is the 64 a cube by 12a. Okay. So now this is actually what? If you simplify, the numerator is what? 1632. 1632 a root a 32 a square by 3. So rho 32 a square by 3 minus, so this is actually what? For 16 by 3, 16 by 3 a square. So final answer, m equal to rho into 16 a square by 3. So I need a rho in terms of m. Rho equal to 3m by 16a square. Okay. So next I need to find the moment of inertia about x-axis. About x-axis is Ix is equal to double integral over a rho into y square into dx dy. Okay. Now this is equal to Ix is equal to integral. I think the limit is same. X is equal to 0 to 4a, and y varies from y square to y square, sorry, x, it took a strip what parallel to x-axis. I think parallel to x-axis. So x is varies from y square by 4a to x is equal to 2 root a y, and y varies from 0 to 4a. Okay, and then rho is what? Rho is 3m by 16a square into y square into dx and then dy. So now this is constant. 3m by 16a square is constant. Integration y equal to 0 to 4a. Okay, keep y square. If you integrate dx, you'll get x. So limits for x is y square by 4a to 2 root ay into dy. Substitute the limits. (3m by 16a square) integration y equal to 0 to 4a y square into 2 root ay minus y square by 4a into dy. So this is equal to 3m by 16a square y equal to 0 to 4a. You have what? This is a 2 into root a y square into y power half, that is y power 5 by 2 minus y power 4 by 4a into dy. So now it is a single integral, integrate with respect to y. So 3m by 16a square, 2 into root a, y power 5 by 2 plus 1 is 7 by 2 divided by 7 by 2 minus y power 5 by 5 into 4, 20a, 0 to 4e. Substitute the limits. 3m by 16a square. So 2 into 2, 4 by 7, 4 by 7, root a. This is 4a power 7 by 2. 4a power 7 by 2. Okay. So that is, I think here it is over. Minus 4a power 5 divided by 20a. Lower limit is 20a. Yes, 20a. Yes. I put 2a, 20a. Lower limit is 0. Okay. So actually this is what? 3m by 16a square is 3m by 16a square. Okay. You have 4 by 7 into root a. This is 4a power whole power 7 by 2. So 4a cube into root of 4a. 4a power 3 into root 4a. Is 4a power half minus 4 power 5. 4 power 5 into a power 5 by a power 4 by 20, and then okay, that's it. Now if you simplify further, you will get what? 3m. Here how many a here have here? A cube, a power 4. Okay, here also a power 4. I think a power 4 is common. A power 4 by 16a square. Okay, remaining you have 4 cube into 4 power 4 into root 4, that is 2 by 7 minus 4 power 5 by, or you can write 4 power 4 into 4 by 20. So I think 4 power 4 is common. 3m a power 4 by 16. I think you can put square because here you have square. 16. 4 power 4 is common. Into remaining you have what? 2 by 7. 2 by 7 minus 4 by 4 I have to count. 4 by 20 means 1 by 5. This is 4 square. This is 4 power 4. So this is 256. This is 16. So remaining 16 into 3, 48 MA square. Okay, if you take 35 is LCM, 10 minus 7. Sorry, yes, minus 7. So this is 3 by 35. Okay, 3 by 35. 48 MA square into 3 by 35. So this is, if you multiply by 48, 144. 144 MA square by 34. So this is the final answer. Okay. So here I gave three practice problem. So first problem is okay. I will do the first problem. Remaining two you can try. I think this is not the answer for this problem, but it is given wrongly. Just the answer is P, but I don't get to P here. Okay. Find the mass of the solid. I think Purnachandra asked the question. So when we use double integral, when we use triple integral, okay. So here you should apply triple integral. Find the mass of the solid bounded by the ellipsoid x square by a square plus y square by b square plus z square by c square equal to 1 under the coordinate planes, where the density at any point p of x comma y comma z is kxyz. Okay, that problem we will discuss now. The remaining problem you can try. Find the moment of inertia of a uniform solid in the form of uh, actant of ellipsoid. Okay, moment of inertia about x-axis they're asking. I think the equations are same equations. I think you can try this one. And find the moment of inertia and the radius of gyration. Actually, radius of gyration is not in the syllabus. Okay, but I will tell you the formula for radius of gyration also. That is, you can easily do it. Okay, about z-axis. Okay, first we will try the first problem number 1. We are going to find what? Mass. Solution of problem 1. So what is the mass formula? Please tell any one of them. I think yesterday I gave.
Triple integral
Yeah, in the last class. Triple integral,
volume
volume,
density
rho into
dx dy dz.
yeah, dx dy dz. Very good, Chandra. Okay, now what is rho? It is given the question. Rho is kxyz. So k xyz over v dx dy dz. So it is better to take the substitution. You should convert in the form of capital X, capital Y, capital Z equal to 1. So let us take capital X is equal to x square by a square, capital Y equal to y square by b square, capital Z equal to z square by c square. Okay. So from this, I need x, small x. X by a equal to what? X by a equal to root x. X is equal to a root x. So dx is equal to a by 2 root x into dx. Similarly, what is small y? Small y equal to b into root y. dy equal to b by 2 root y into dy. And then small z equal to c into root z, root capital Z. D small z equal to c by 2 root capital Z into d capital Z. Okay, now substitute, replace x small xyz in terms of capital XYZ. So xyz is what? A, B, C into root x, root y, root z. A, B, C into root x, root y, root z. Okay. And then dx, dy, dz. 1 by 2, 1 by 2, 1 by 2. Okay, va? A, B, C. So A, B, C by 8 divided by root x, root y, root z. A, B, C divided by root x, root capital X, root capital Y, root capital Z into dz, dy, dx. Capital Z varies from where to where?
Sir, 1/8 வரும்ல sir.
1 by 8. Okay, correct. Okay, 1 by 8 I'll write here. Thank you, Kalvini. What Z where capital Z varies from where to where?
From 0 to 1 minus x minus y.
Yeah, 0 to 1 minus capital X minus capital Y. Okay, wow. So in the form of tetrahedron. Capital X, capital Y, capital Z. And then after the projection, this is x plus y equal to 1. So take a strip parallel to y axis. Y varies from where to where? 0 to 1 minus x, and x varies from
0 to 1, sir.
0 to 1. Okay, so now you have what? K into a square, b square, c square by 8 is constant. So the root x, root y, root z cancelled. 0 to 1, y equal to 0 to 1 minus x. If you integrate with respect to z, you will get z into capital Z into 0 to 1 minus x minus y into dy into dx. So this is equal to k into a square, b square, c square by 8 by 8. Substitute the, okay, capital X is equal to 0 to 1, capital Y equal to 0 to 1 minus x. Substitute the limits for z, 1 minus x minus y into dy into dx. Okay, now integrate with respect to y. So k into a square, b square, c square by 8. Capital X is equal to 0 to 1. So 1 minus x is constant because you are integrating with respect to y. So 1 minus x into capital Y minus y square by 2. If you integrate y, you get y square by 2. The limit is from y equal to 0 to 1 minus capital X into dx. Okay. Next step, substitute the limits for y. So k into a square, b square, c square by 8. Okay, integration x is equal to 0 to 1. If you substitute the upper limit, you'll get what? 1 minus x into 1 minus x. So 1 minus x into 1 minus x is 1 minus x whole square minus upper limit is what? 1 minus x here square by 2. Lower limit is 0, 0 into dx. Okay. So this is equal to k into a square, b square, c square by 8. Integration x is equal to 0 to 1. Okay, this is what? 1 minus x whole square by 2. Okay, we simplify this into dx. So now this is actually Okay. This is actually what? Okay, I'll write the next step. K into A square, B square, C square divided by 8 into 2, 16. Okay. If you integrate 1 minus x whole square, you will get directly 1 minus x whole cube divided by 3 into, if you differentiate minus x, you'll get minus 1. So the limit is from 0 to 1. Okay, so this is equal to k a square b square c square by 16 or 16 into minus 3. Okay, 16 into minus 3. Upper limit is 1 minus 1, 0. Lower limit is 1. The final answer is k a square b square c square by 48. So this is the final answer. Okay. So now, so you can, okay, what is the formula for the second problem? Moment of inertia. About which axis? About x-axis. What is the formula? Mi. Is what?
Triple integral.
Ix is equal to
Triple integral.
not double integral, triple integral.
Yes, sir. Triple integral.
Triple integral
Or V.
or V
Rho into
rho into
so over x. X, sir, about x, sir.
about x-axis, because about x-axis, yes.
Then x square plus z square.
No, please check it. Y square plus
Y
z
square plus z square, sir.
Okay, y square plus z square. Okay. Y square plus z square into what? Dx, dy, dz. Dx, dy, dz. Okay. But the final answer is in terms of what? M. Okay, in terms of M. So first you need to find what? Mass. Okay, you need to find the mass. So for mass, what is the formula? I think you know that M equal to triple integral over V rho into
dx, dy, dz.
dx, dy, dz. Okay, I think just now only we got the answer. Is it correct for this part? Yes or no, Paul? Whether we got the answer for the same problem?
Yes, sir. Yes, sir. Same.
Yes, but here, there you have what? Density is what? Kxyz. But here, just you should keep rho. Just rho. There is no need to substitute kxyz. Okay, so just to keep rho or dx, dy, dz. Okay, and then you need to integrate, find m in terms of rho, finally rho in terms of m, and then substitute here and try to get the answer, this answer. So please try. So if you got the answer, you can post in the group. And similarly, third problem, find the moment of inertia. Okay, okay, mi about z-axis, Okay, that means you should find ix and iy, which is the first octant bounded by x by a plus y by b plus z by c equal to 1. So you'll get this answer. So try. Suppose if you don't get it, you may contact me. Okay. First, if possible, you can discuss yourself. Otherwise, you can contact me. Not today, tomorrow. First, you should try today. Okay. So I think I gave only 2 problems, a practice problem. What is time? Okay, still I have time. I think last class I gave practice problem. Okay, I will, before going to the practice problem, first I want to give problem number 4, practice problem. Evaluate triple integral x square y z dx dy dz taken throughout the volume, taken throughout the volume in the first attempt bounded by x is equal to 0, y equal to 0, z equal to 0, and x by a plus y by b plus z by c equal to 1, equal to 1. So the final answer for this problem is answer a cube b square c square by 2520. So how to solve this problem? Just to give the idea, and then I will go to the next problem.
Sir, taking x by a is equal to capital X, sir.
X by a is capital X.
X plus capital Y plus capital Z is equal to 1.
So y by b equal to capital Y, and z by c equal to capital Z. So this is the idea. So you should convert into the given region into tetrahedron, and then you should find small x, small y, small z, and then you should replace here, and then dx, dy, dz, and then you should replace here. Okay, and then try to get the answer. Next problem. Fifth problem, evaluate triple integral root of xyz into 1 minus x minus y minus z into dx dy dz taken over x is equal to 0, y equal to 0, z equal to 0, and x plus y plus z equal to 1. X plus y plus z equal to 1. Okay. Here, just to give a hint, you can try. Here, I think it is in the form of x plus y plus z equal to 1. Okay, solution I equal to triple integral. Okay, well, I think first I'm going to integrate first with respect to z. So z varies from where to where?
0 to 1 minus x minus 2.
Yeah, 0 to 1 minus x minus y. Y varies from
0 to 1 minus x.
1 minus x. X varies from
1, 0 to 1.
yeah, 0 to 1. So if you look at this type of equation, x plus y plus z equal to 1. So this is a limits, okay? And okay, root xy. Okay, root xy is constant because it is we're integrating with respect to what? Z first. Okay, so and then root z. I split like this into root of 1 minus x minus y minus z into dz dy dx. So that's why I would write x is equal to 0 to 1, y equal to 0 to 1 minus x to root xy, and then write z equal to 0 to 1 minus x minus y into root z into root of 1 minus x minus y minus z into dz dy dx. I think you know the result. 0 to a something. Okay, if you use that result, what you will get?
1 minus x minus y whole power 3 by 2
0 to 1,
minus
y equal to 0 to 1 minus x.
1 minus x minus y whole power.
Root xy 1 minus x minus y, that is a va?
Yes, sir.
1 minus x minus y. What is m?
3 by 2. 3 by
Yeah, because this is here have half. Okay, 3 by 2 minus 1. Okay, half plus
Sir, m is equal to 3 by 2, sir.
okay, sorry, m equal to 3 by 2. What is n?
3 by 2, sir.
Yeah, 3 by 2 plus 3 by 2 minus 1 beta of
3 by 2, comma 3 by 2.
3 by 2 comma 3 by 2 into dy into dx. Okay, please tell the result once again. Integral 0 to a
Pi power m.
sorry,
Pi, sir.
pi
Y, sir. Y
y,
power
yes, y power
m minus 1.
m minus 1 into 1 minus y,
A minus y, sir.
yes, a minus 1. A minus y
Whole
whole
power
power n minus
m
1
minus 1.
into dy equal to
A
a power
m plus n minus 1.
m plus n minus 1 into
Beta
beta of
m comma n.
m comma. Okay. So at least you should mention, if you use this result in the column, you should mention at least once in the solution. Now, a beta of 3 by 2 comma 3 by 2 is constant. Okay, now integration x is equal to 0 to 1. And then I think root x you can write here. And then and also dx you can write here. What is remaining? Y equal to, this is capital Y. This is capital Y, this is capital X. Y equal to 0 to 1 minus x. What is the integrand? Root y into what? I don't have enough space. That's why I'll erase it.
Sir, no need to write capital Y and capital X, no, sir.
Yes, everything is smaller.
Yes, sir.
Yes. Okay. So now this is what? X is equal to 0 to 1. This is y equal to 0 to 1 minus x into dy dx. This is y equal to 0 to 1 minus x into what is the integrand? Integrand is root xy. Root x I wrote here into root y into 1 minus x minus y whole power 2 2 into dy. So now this is what? Beta of 3 by 2 comma 3 by 2 integration x is equal to 0 to 1 root x into dx. So again apply that result, you will get what? 1 minus x whole power 3 by 2 plus 3 minus 1 into beta of 3 by 2 comma 3. So the next step, I think, can you proceed the remaining part? I think this is just an integration. Okay, so try to get the final answer. What is the final answer I gave? Okay, I don't give the final answer. So try to proceed and get the final answer is, I will write the final answer.
As in x square by 960.
Sorry, I think where I guess here 3 by 2 comma 3 no. In the problem I think it is not, again it is not in the order. So okay, should carefully watch the video. Okay, so Uddhavan, please tell. Uddhavan, what is the answer? You got it?
Sir, pi square by 960.
Yeah, pi square by correct, pi
960.
square 1920 okay. So I will give the next problem. I think yes, I gave this problem. It's a practice problem last class. Anybody got the answer? I'll just write the problem. If you got the answer, you can post the group. Find the mass. I think I gave two problems. One problem I think Purnachandra solved and sent to me. Purnachandra, please post that problem now in the group. Find the mass of the lamina of density rho is equal to x plus y occupying the region or under the curve y equal to what? X square in the interval 0 less than or equal to x less than or equal to 2. I think I gave the diagram also. So anybody got the answer for this problem? Here what? What is the curve? Y x square equal to y means this is x square equal to y or y equal to x square, and x varies from 0. This is x equal to 0. X is equal to 2. So this is the shaded region is the common region because it shows it is under the curve. Okay, this point is what? When x is equal to 2, y is 4. This is 4 comma 2. This is 2 comma 0. This is the origin 0, comma 0. Okay. So if you take a strip parallel to x-axis, so I equal to, mass, mass. For mass, what is the formula? Double integral over A rho into dx dy. What is the rho? Rho is x plus y into dx into dy. So x varies from where to where? Here what is x? Root y, yeah. Root y. 2. Here what is x? 2. Y varies from where to where? Y varies from where to where? Y varies from 0 to 4. I think I wrote here wrongly. This should be what? X is 2, y is 4. So y varies from 0 to 4. So now you need to integrate and try to get the answer. I think in the last class I gave the answer for this problem is 36 by 5. So you need to verify it. So only thing you need to integrate this. Okay, and then I'll give 2 more problems and then I will stop the class. Okay, so find the mass of the tetrahedron bounded by the coordinate planes x is equal to 0, y equal to 0, z equal to 0, and the plane x by a plus y by b plus z by c equal to 1. The variable density rho equal to mu xyz. The solution. So I think they are asking what? Mass of the tetrahedron. So mass is equal to triple integral over v rho into what? Dx dy dz or dz, okay, dx dz dy dx. But here it is given in the form of what? X by a plus y by b plus z by c. Take this is capital X, this is capital Y, this is capital Z. Okay, and then proceed. Okay, the final answer for this problem is mu into a square b square plus c square divided by 720. Assuming the solid has a constant constant density K, find mi, moment of inertia for a cube with side length L, if one vertex is at origin, one vertex is at origin 0, 0, 0, and three sides lie along the coordinate axis. Coordinate axis. Okay, so here also I give the hint. So assuming the solid has a constant density, so rho equal to K. So we need to find the moment of inertia for a cube with a side length L. So they don't give about x-axis or y-axis or z-axis. Okay, so then it is enough to find any one of the axis. Either you can find moment of inertia about x-axis or y-axis or z-axis. Okay, I will find moment of inertia about x-axis. So what is the formula? Triple integral over V. Please tell anyone.
Y square plus L
Y
square.
square plus Z square.
Rho into
Yes, sir. Rho into
rho into y square plus z square into dx
Yeah.
dy dz. Okay. What about the limits here? What about the limits? X,
0 to L, sir.
very good. 0 to L. Y where is from?
Same 0 to L, sir.
Very good.
Up to
The one 0 to L, 0 to L. Because it is given that for a cube with side length L, if one vertex is at the origin 0, 0, 0. Okay. So now rho is K into y square plus z square into dx dy dz. So that's all. So you need to proceed and find the answer. Answer is Ix is equal to Ix is 2K into L power 5 by 2K L power 5 by 3. So how many problems I gave? So please check it. How many practice problem I gave? 1. Okay, this is 1. This is also 2.
4, sir.
2. Okay, this problem, if you solved, okay, otherwise you can try 3. And then this one, partially I solved 4. Remaining you need to solve 5, 6, 7. So these two are little bit important one. Okay, because I took this is from H.K. Das. So all the 3 from H.K. Das. So you should try these 2 columns first and then try remaining columns. And if you have any doubts, you can contact me. Okay. So I am expecting for the third CA, one question from moment of inertia or mass or volume. Okay, there is application part. for the third CA. I don't know about final exam. At least for the third CA, I am expecting one question from the last. Either the question will come from today class or the previous class. Okay, I think the syllabus is. I finished the syllabus. Only thing you need to practice more. Already you have enough practice. Okay. So those who are trying regularly the assignment problems have very good practice. So I don't have, there is no doubt. Okay. Okay, after the third CA, I am planning to conduct a test if you wish. Okay, if you wish. You can tell. Okay, just 1 hour test if you wish. Otherwise, I will send you a question. You can practice. That is up to you. Okay, anything else you want to? Any doubts? Okay, thank you. So we will meet February 21 in Shastra. Okay, thank you everyone.
Thank you, sir.
Thank you, sir.
Thank you.
Thank you.